Hello and welcome to Honors Function. In this lecture, we're gonna follow up the remainder theorem that we covered in the previous lecture with the factor theorem. These two results do go hand in hand. Let's begin. So for the factor theorem, we will take a polynomial p of x, and here is the result. X minus a is a factor of p of x if and only if, okay, you read that as if and only if, it's a biconditional, a is a zero of p of x, and that means that p of a is equal to 0, okay? So x minus a is a factor if and only if p of a is equal to 0. This by now should be really trivial. It's an if and only if, so we have two things to show. Let's show that if you have a factor, then you have a 0. So what is a factor? If you look at the first definition from the previous set of notes, it's this expression. For example, we can express p of x as x minus a times q of x, and so now if you look at p of a, so p of a is a minus a times q of a. I don't know what q of a is, but I sure know that this is 0, and so it is 0. So if x minus a is a factor, p of a is equal to 0, a is a 0. Now let's show the theorem in the other direction. So what about if p of a is equal to 0? What about if a is a factor? Then if you divide p of x by x minus a, if we do the long division, or the synthetic, of p of x divided by x minus a, we're gonna find a quotient and we're gonna find a remainder. And we know that the remainder is going to be p of a. Okay, now if p of a is equal to 0, then x minus a is a factor of p of x. So again, this is really trivial. Let's look at the first example. So guys, in my note, I made a mistake in writing this function. I forgot the quadratic term and I put a plus 3 instead of a minus 3. This is the correct polynomial that I want to factor. Okay, now if I ask you before this lesson to factor this expression, I don't think anyone would have been able to do it. A grouping would not work, and this is not an expansion of a cube. So how do you do? I'm going to show you how to use the factor theorem. So first I'm telling you to check that x plus 1 is a factor of f of x. So we're going to do that by checking that f of negative 1 is equal to 0, okay, and that's a question mark. I need to check it. And if f of negative 1 is 0, then x plus 1 will be a factor. So let's check this out. We're going to do a synthetic division or synthetic substitution. So negative 1, 2, 7, 2, negative 3. Then what do we have? 2, negative 2, 5, negative 5, negative 3, 3, 0. So yes, f of this is where you read f of negative 1, right? So f of negative 1 is equal to 0. Therefore, x plus 1 is a factor. What is the quotient polynomial? It's written, well, the coefficient of the quotient polynomials are right here. And therefore, we can write f of x as f of x equals, so x plus 1 times the quotient polynomial 2x squared plus 5x minus 3. And this should be very nice to factor. So it's a 2x, x. If I want a 5, I probably need to bring a 6, and I need a plus 6 minus 1 plus 5. Here we go. Here is the factorization of f of x. So this tool, the factor theorem, gave me, and the synthetic division, of course, and the remainder theorem, gave me a new way to factor some polynomials, okay? I'll let you do number 2. It's a little bit longer than this one. It's a degree 4. Let's go over how to do successive synthetic division. Okay, so suppose you have a polynomial function, f of x, and you know two zeros, two roots of the polynomial function. How can you use this fact to break down the polynomial using the synthetic division? So let me first use the fact that a is a 0. If a is a 0, then I can write the polynomial as x minus a times a quotient, right, q of x. But now, we also know that b is another 0. So if you plug x equals b in this one. You got f of b is equal to b minus a times q of b, right? Now, b is a 0 of f, so this is 0 right here, okay? So we have 0 equals, now, we're going to assume that a and b are different, okay? b minus a times q of b, right here, this is the time, okay? And b minus a is not 0, therefore q of b has to be 0. So if b is another root, it is a root of the quotient. It's a root of the quotient. So when you do your synthetic division right here, you're going to start with a, and you're going to write the coefficient of f right here. You're going to do the synthetic division, and right here, you would have the coefficient of the quotient right here. Okay, you had f of x right here, the coefficient of the dividend right here, and here you have the coefficient of the quotient. Well, what you're going to do at this point is do another synthetic division, and you should find at the end a 0 for the remainder because b is a root of q. The same as a was a root of f, b should be a root of q because it's a root of f. Let me show you what I mean concretely. I'm going to do example number 3, and I will let you do the last example. So you have to do example number 2 and number 4 here, okay? Alright, example number 2, show that x equals 2 and x equals negative 2 are two roots of the polynomial, and then factor f of x completely. So let me check that 2 is a root of the polynomial by doing a synthetic division, and hopefully in the end I should have a 0 right here, right? So we have 1, negative 3, negative 2, 12, and negative 8. So bring down the 1 times 2, 2 minus 1 times 2, negative 2, negative 4 times 2, negative 8, 4 times 2, 8, 0. Yes, f of 2 is equal to 0. Now let's check the same thing with negative 2 right here. So 1, negative 3, negative 2, 12, and negative 8. So let's do it again. Bring down the 1, negative 2, negative 5, 10, 8, negative 16, negative 4, 8, 0. Yes, negative 4 disappeared. 0. So f of negative 2 is also a 0. Now, what are you going to do with this information? Well, I'm going to take one of the two synthetic division, for example, this one right here, and I'm going to do a second synthetic division with negative 2 right here. So let me erase that. Let's continue the division on the quotient, right? So 1, negative 2, negative 3, negative 3 times negative 2, 6, that's 2, that's negative 4, and that's 0. You see how negative 2 is a 0 of the quotient right here? Okay, now let's do the factorization. So we have f of x equals, so 2 is a 0, so x minus 2 is a factor. Negative 2 is a 0, so x plus 2 is a factor. And now what's a quotient? Well, that was a degree 4, that is a degree 3, therefore that is a degree 2. So we have x squared minus 3x plus 2, and we have then our factorization, right? It is x minus 2 times x plus 2 times x minus 2 times x minus 1. Right here, other way to write it, x minus 2 squared times x plus 2 times x minus 1. Here we go. Here's a factorization of the degree 4 polynomial I gave you. That's it for this short lesson. Thank you for watching.